Hi everyone, so let's continue working with chapter 5, and this time our lesson will be on systems of linear equations in two variables. For this particular topic, we will be working on deciding whether an ordered pair is a solution to a linear system. We will solve systems using three methods: graphing, substitution, and addition, or technically it's elimination. We will identify systems that do not have exactly one ordered pair solution, and also how we can apply solving systems on word problems. So let's have some definitions first. So when we have two linear equations, two or more actually, but we're just going to focus on two for this topic. It is what we call as a system of linear equations, or simply linear system. So when we have a solution to a linear system or a linear equation, it means that it is an ordered pair. It is a point. It's an xy value that can satisfy both equations in the system. So when we talk about satisfy both equations, it means that if you replace the x and the y values into equation number 1 and into equation number 2, and they both become true, then it means that we have a solution. So let's take a look at this example. So we have the ordered pair 1, 2. We need to check if it is a solution to the system 2x minus 3y equals -4, and the other one is 2x plus y equals 4. So when we are checking, okay, we do not know if 1, 2 is a solution or not. So what we need to do is to evaluate, okay? We put the value of x, this is our x value, sorry, and this is our y value. So we will replace the x and y in each equation by the given values here, which is our ordered pair. And let us see if we can come up with a true statement. So let's start with the first one. So we have 2 times the x value, which is 1, minus 3 times the y value, which is 2. Is this really equal to -4? Okay, that's what we will be looking at. So if we work on this, this is going to be 2 minus 3 times 2 is 6. Is this really equal to -4? And if you take a look, 2 minus 6 is actually -4. Is it equal to -4? Yes. So 1, 2, the order pair 1, 2 satisfy the first equation. So this is good. Okay. Now let's take a look at the second equation. So again, we replace our x and y with the values given. 2 times 1 plus y, which is 2. Is this going to be equal to 4? And if we simplify this, this is 2 plus 2. Oops, sorry. Is this equal to 4? 2 plus 2 is indeed, 2 plus 2 is indeed equal to 4. And this is again true, which means, as you can see, both of the equations were satisfied. Therefore, is 1, 2 a solution? Yes. 1, 2 is a solution to these two equations. All right. So now, what are the methods of solving systems of equations? Basically, there are three most common methods of solving systems of equations, and I'm pretty sure you have been familiar with that, especially with Algebra 1. We start with graphing, and then we also have solving by substitution and also by elimination. So out of the three, solving systems with graphing is the easiest, mainly because all you need to do is, if you have a graphing calculator, you type in your equation, and then you look for the point of intersection. Okay, so let's say if you have first equation is graphed like this, and then the second equation is looking like this, then your solution is simply this point over here. That is the solution. And remember, this solution is a point, which means you will have a value of x and a value of y. All right. So in this case, the only thing that I will be recommending for you, if you're going to be using a graphing calculator, is Desmos. Okay, this is only our legit calculator. No other fancy calculators to use. I can have you work with the TI-84, which we can work together in class. All right. So let's begin our example. So we have our two equations here, x plus 2y equals 2, and then the other one is x minus 2y equals 6. So if you have your graphing calculator, let me just, oops, sorry, my bad. Okay, so if you are on Desmos, you gotta go to desmos.com/practice and you choose the graphing calculator, and there we go. So if we are going to go back to that equation, that should be, you copy it here, x plus 2y is equal to 2. Okay, so that is your graph. And then we have the second graph, second equation, x minus 2y is equal to 6. All right. So if you can see here, nice thing about Desmos is that the lines or the equations are graphed in different colors. So this graph here is the red equation, the 2x plus 2y. And the blue equation, the blue line is the blue equation here, x minus 2y. And you can take a look that the point of intersection, if you click on it, there is an intersection at 4, -1. So what does 4, -1 mean? Okay, so our point of intersection, let's go back over here. Our point of intersection, oops, sorry, my bad. The point of intersection, according to our graph, is 4, -1. So what does that mean? If we replace x and the y value into these equations, those equations will be true. And you can check. So let's have x to be 4. So this is 4 plus 2 times the y, which is -1. Is it going to be equal to +2? And you will see this is 4. +2 times -1 is a -2. Is that going to be equal to 2? Yes, it is. 2 is equal to 2. And again, you can replace the 4, -1 into the second equation. 4 minus 2 times the y, which is -1. Is this going to be equal to 6? So -2 and -1, that's going to be a +2. 4 plus 2, is that indeed a 6? Yes, it is. Okay, so just by looking at our graph, okay, let me discard this. Okay, so if you have your systems graphed onto your in your Desmos calculator, all you need to do is find for the point of intersection. Now the main question will be like this: Miss, how am I going to graph this on MATLAB? Okay, well, you need to find key points so that you can easily graph your two lines and copy this, you can replicate this graph into your MATLAB. So for example, let me deactivate the blue graph first. How are you going to graph the x plus 2y equals 2 on your MATLAB? Well, you're going to think of, or you're going to look at points of intersection on your x and y axis, since your intercepts are the easiest way to do that. So you have 2 points here. You have 1 point at +1 on y and another point at x equals 2. So that identifying those key points can help you graph x plus 2y equals 2 on your MATLAB assignment. Now, for the blue graph, same scenario. So once you have it graphed, take a look. Where did it intersect on the y-axis? Oh, it perfectly intersected at -3, and on the y, on the x, I should say, it perfectly intersected at 6. Okay, so now, Miss, what if they are not in exact locations on the x and y axis? Well, you gotta be observant as to where there will be some points of intersection. Like for this one here, if you can determine this particular point here, you can see, oh, there's a -2 point. Okay, so you have to be observant. This one is an exact point as well. There's a 10-2 point as well. Okay, so if ever you do not have exact points on your x and y axis, please make sure that you take a look or identify some points of exact points over here, like this one, -2, 2. That's another point. Okay, you can observe it easily with Desmos. It's a lot more challenging with the TI-84. That is why I am telling you to be able to use Desmos when working with systems of equation, especially with graphing. Out of the three, graphing is the easiest, mainly because all you need to do is type your equations, look for the point of intersection. That's it. That's your x value, and that's your y value already in there. Unlike substitution and elimination, you have to do some computations in there. But the thing with graphing, the only problem here with graphing is that sometimes the point of intersection will not be an exact value, like this one. This is a 4, -1. Sometimes you might have intersections to be at fractions or at decimals, so you might need to be very careful with those. So that's why we always have other methods to check the solution for our